Hey guys, Chili here. Welcome back to Intermediate C++. I got for you a little bit of a bonus video here. This is meant to be watched after the video on smart pointers, after the video on unique pointer. And what I'm going to be showing you here is some improvements on the surface class. So in the unique pointer video, we overhauled surface. We made it manage its memory with a unique pointer. And that allowed us to do things like we didn't need to define the destructor anymore. We could just use the default one. And we could just also set the move operations to default, and that seemed to work fine for us. So that's a big improvement over managing it yourself manually, but we can actually do better. So what I'm going to do in this video is we're going to replace well, first off, you might be saying, well, what happened to the unique pointer? And that's a good question. I don't know what happened to it, but it's gone now, and it doesn't really matter, because what we're going to do is we're actually now going to implement it using vector, std vector. And that's going to be great because std vector has logic for the deep copy and for the moving, and we can go back down to rule of 0, or well, maybe not. Well, we'll see. You'll see. Now you might be asking, well, Chili, why didn't you just use a motherfucking std vector to begin with? And that's a good question. In fact, it's probably what I should have done, except I had two motivations. Motivation number one is I wanted to show you the steps of first having to manage the memory yourself manually, and then the advantages of smart pointer, and finally bring it home with the advantages of vector. So I wanted to take you through the journey, so we had to start at a shittier implementation and work our way up to the good stuff. That's one reason. Reason number two is a little more complicated, a little more messy, but basically the thing about std vector in particular is when we're going to access that memory with std vector, there's going to be a lot of, how do I say this? There's a lot of overhead of functions that call other functions, and overhead of safety checks that happen. That kind of overhead doesn't happen when you just have you managing the memory yourself. And you might say, well, Chili, overhead, that sounds bad. Maybe I don't want to use std vector. And the thing about this is when you build in release, that overhead goes away. The compiler inlines all the functions, folds them all down, gets rid of all the middleman bullshit, and then optimizes what's left. And in the end, you're not going to be paying for all that extra abstraction and all that extra safety. You get the safety, you get the abstraction, but you don't pay for it because it all goes away in the release build. In the debug build, it stays in there, but that's fine because debug build is about verifying and about testing. It's not about getting good performance. So that's fine, except, and here's the thing, here's the nasty little detail. Sure, we shouldn't care about performance in debug, except in the special case where we are calling that function millions of times a second, potentially millions of times a second. And then if that function is much slower, it might slow our program down so slow in debug that we can't run it anymore. We can't verify or do any testing because it's too goddamn slow. And that is indeed what happens with putPixel and related functions, because it's just so much of it going on. Normally, don't worry about performance in the debug mode. Don't sweat it. But sometimes you gotta sweat it, and that's what I'm going to do in this video. I am going to implement a surface that manages its memory with the std vector. Very nice semantics, but I'm also going to optimize it so that the motherfucker runs pretty goddamn fast. I mean, not as fast as release, obviously, but you're going to see huge improvements here. First thing is first, let's take a look at the history. What I've done is I've created a little class here called the bencher, and it just takes a bunch of measurements over a number of frames, and it gives you the average, the min, and the maximum, and gives you a way of formatting that information, outputting it. It's just a nice little benchmarking class here. Then in game.cpp here, what am I doing? Sprite Effect. So I create a vector of positions, just vec2s, and then in here I am going to draw Sprite. I'm going to draw a large Sprite at each of those positions. So I'm drawing, I think, 50 very large. It's a whole Sprite sheet is what it is. And here, so yeah, I draw that, and here I take the bencher start, the bencher end, and if it returns true, that means that it's done a batch and should output the results for that batch of frames. So that is how she do. If I run this is actually different code, doesn't matter. If I run this, you will see what it looks like running the benchmark code. It just looks like this. It's just drawing this link sprite sheet, I don't know how many times, like 50 times. So it's a good test. It's pushing a lot of pixels is what it's doing. And if we look at benches.txt, this is where I record the benchmark values for all the different changes that I've made. And this is actually like pretty important when you're making changes and when you're trying to do optimizations. Rule number one is you measure everything. You don't just assume shit. If you're optimizing and you're not measuring, you're motherfucking doing it wrong. That's the first thing anyone will ever tell you, is you've got to measure your results. And it can be tricky because oftentimes benchmarks, if they are too trivial, and you, especially in release mode, if the compiler can see that the work you're doing is useless work, it can actually just remove all that work, and you'll get bad results for your measurements. But anyways, that's not a real issue for us. But the one important issue is, yes, measure your results, but also freaking record the results. Keep notes, keep good notes of your results, because it can be hard to figure out what things were better and what things were worse after you make a whole bunch of different changes. Results can get muddied, and you're now remember, was it faster when I did this change, or was it faster with this change? I don't really remember. Maybe I should have written that shit down. So here we've got just the current code here without any changes. In the original version, release mode takes about 6.6 milliseconds on average to draw those frames. And in debug, you can see here a huge difference. Orders of magnitude difference. And so yeah, it's much different. It's really slow. Debug is really slow. And there's a bunch of reasons for that. I think probably the biggest loss that we get here is every pixel that we draw, it's got to call the sprite effect. It's got to invoke this sprite effect to get the color, and that is slow. Obviously, when you run in release, all that sprite effect code gets inlined, gets folded together, gets optimized, and it's not a big issue. It's not a big issue, but in debug, it is a huge issue, and it's something that we're going to have to address at a certain point, but that's a little bit later. The first thing that we want to be doing here is let's go see if I can find my freaking, there's my history. Why does this fucking window always disappear on me? It pisses me off. Anyways, so surface as graphics buffer, what is that? Well, the first thing I did was I got this idea. What I want to do is, instead of having, you know, manually managed array of colors, array of pixels, what I want to do is just use a surface for the system buffer in graphics, because it has put pixel, has get pixel. I could just use this and it would be a lot cleaner, and it is a lot nicer situation. And so that is what I did. And in surface.h, I added a few functions. I added the fill function, and I added data function to get just a pointer to the pixels. And those are used in graphics to implement a bunch of the things that you have to do. If I bench this, I find that it's slower. It's a little bit slower, which is, it's expected that the debug is going to be slower when you add a little bit of extra abstraction. But what is disappointing to me is that it's not only the debug, the release is also slower, significantly slower. This is not a small amount. This is almost a 50% reduction in speed, depending on how you calculate it. So, I don't really, in hindsight, not sure about this. But anyways, we move forward. The next thing we want to do is we want to use vector now to manage this stuff. So by using vector, what we can do is we can basically do rule of zero now, right? We don't have to supply a copy constructor, don't have to supply move constructor, and ditto for the assignment. And of course, we don't need the destructor anymore. So we can remove all that stuff So much better, so much sexier. Look at how this code just gone. Just see you. Wouldn't want to be you. And, you know, a bunch of other stuff down here changes a little bit. It's not a big deal. It's not really a huge change, all said. This allocation just becomes pixels.resize. And yeah, that's it. And when you check the branches on that, you're going to see that actually the release doesn't change at all, which is expected because we expect the compiler to fold out all of that extra abstraction. But look at the motherfucking debug. It went up to 5,000 milliseconds per frame. So it over tripled the amount of time it takes to render. And this was already slow as fuck for debugging. This is just freaking cancer to our time cancer. It's not good. So obviously we're going to need to do some things. And what I did in here is better optimization settings for surface.cpp. Now this one you can't really see in here if I double click this. So what I'm going to do is show you the settings that I changed. So what I did here is in surface.cpp, I went to properties and I went to CPP and I changed the optimization. I gave this one full optimizations for this source file only. So by implementing the optimization, by enabling it, it means that when I debug this file, it's not going to be as easy to understand what is going on in the code. It's not going to be as straightforward. I also changed it to favor fast code. And I think I made a few other changes. I disabled security checks. So that means that this code isn't going to be faster, but also a little less easier to debug. But generally, when you're debugging, you're not debugging surface.cpp, right? You've probably gotten that one already pretty solid. So, and I still keep the assertions in here, so it's still doing the bounds checking, which is the most important part when you're debugging. And now by doing this, the benchmark here, look at the debug. So optimization in surface.cpp went from 5,000 milliseconds to 789 milliseconds. A huge gain, better than we started with, even though we are using vector here. So obviously, putting that optimization in there, very important. So we want to do that for sure. Now, the next little optimization I make is I use data instead of using the access operator, because the indexing access operator for vector does some bounds checking, but we're already doing bounds checking in 2 dimensions here. So this one-dimensional bounds checking that it normally does in debug, that is just superfluous. It's a waste. So instead, we just get the pointer and then access directly using that, and that should be a little faster. If we take a look at benchmark.txt, we can see, yeah, it got a little bit faster, maybe a 5% increase in speed. Nothing amazing, but we'll take it. You know what? We'll take it. Now, next thing I did is separate CPP for optimized debug functions. So basically, in surface.cpp, we were setting the whole thing to have full optimizations. But really, we only need optimizations for put pixel, get pixel, and maybe fill. That's really the only ones that we're worried about the performance for. So instead of putting the whole file in full optimization mode and making it hard to debug all the functions in here, we'll only put optimization for the ones that need it, and the rest of them we'll leave it unoptimized so that they are better for debugging. So we'll only make it hard. We'll only make the ones that are absolutely necessary. We'll only make them hard to debug. We'll limit the damage basically. And I do that for Surface, but I also do it for graphics.cpp. I pull out the put pixel and get pixel because optimizing those should also give us some benefit. Optimizing the call to put pixel, so that should allow it maybe to maybe inline in here. I don't think it's possible, but it might be. At any rate, when I do this, you will see I get another big speed up because now it's gone down to 400 milliseconds from 751. So we're getting already from our start we're now 3 times faster, and we're doing, we've got a better code base because we're using rule of 0 and we're using std vector. So better code, faster code, you can't complain with that. Now what I done is, because I noticed that the release mode was slower when I was using Surface, I reverted back to just color pointer. And in doing that, you can see basically there was no change in the debug, but the release went back down to 6.4 milliseconds, which is pretty much what we had at the beginning here. 6.62, 6.4, yeah, about the same speed in release now. So that reversion, that was pretty much necessary. You don't want to sacrifice your release speed for a little nicer code base. I don't know, 50% slower to get a little bit nicer code. That's, I don't think it's a good trade-off. So going back to the naked pointers for this one, and it might be worthwhile to try out unique pointer there and see how it works, but maybe someday. Surface move test. Okay, here is a problem that we're gonna have. And so we did rule of 0. We default all of our move operators. And that's cool, except when you move from one surface into another, it steals the resources, but it keeps the dimensions the same. So I forget the dimension of this, but let's say it's 400 by 300, okay? When it moves out of here, the original, the donor, still thinks it has a 400 by 300 image, and when you try to draw to it, the assertions aren't going to work properly. So what we want to do is, when we steal resources from one surface to another, we want to set that surface's width and height to 0. So that means that, unfortunately, we can't do rule of 0 here. We're going to have to implement some stuff in here. It's going to be a very simple implementation. So what we do, surface.h, we add the move operations, and we default the copy. The copy can be the same. We don't need to implement any behavior for that because the default does exactly what we need. But for the move, what we got to do is we got to copy over the width and the height. We move the resources from one vector to another, and then we got to set the width and the height of the source to 0. And then for the move constructor, we can just invoke the move assignment to do the work for us. So we got to do a little bit of work there, but that will make our move maintain proper width and height for the donor surface, the donor. And then I remove this test code, fix annoying build warning. Now, here is the final speed up, and it is incredible. So basically, what I told you before was that the problem that we were having, the main performance problem, is the fact that the put pixel, the draw sprite, has to invoke the sprite effect for every single pixel that's drawn, and those function calls, the overhead adds up to huge slowdowns. Now what we can do is we can make the compiler compile that templated function, draw sprite, inside of our optimized graphics od.cpp file, because this one is optimization enabled. If it compiles that template function in here, if it instantiates the template in here, then we're going to get the optimized version. Normally what the compiler does is it instantiates the template separately in all the different object files, and then when it's time to link them, it picks one instantiation from among the identical ones. It picks one and it discards the rest, and it links the other ones to the one implementation that is chosen. So what we can do is, in graphics.h here, we can declare in the header file extern template, and then we can void graphics draw sprite and on sprite effect copy. So what this is saying is that all the guys that include this template, it tells them, don't try to instantiate this yourself, because there is going to be a copy of it that exists, and you are going to link to that copy. So don't try and instantiate this in yourself. So everyone who includes this is not going to try to compile this function themselves. They're going to defer compilation and wait for linking to find an implementation. Now, we still need one implementation. So what I do is I do an if not defined here, God graphics. So it'll only put this extern if God graphics is not defined. And then in graphics OD, before I include graphics, I define God graphics. So that disables this extern template, and that will cause the compiler to actually instantiate the template in this CPP file. And this will be the canonical implementation of the function. And since the canonical implementation, the one that all the others are going to link to, was compiled with full optimizations enabled, this is going to be very fast. It is going to have the template, the Sprite Effect copy functor. That functor is going to be inlined into this template compiled code here, and it is going to be bloody fast. How fast? Well, let's take a look. How do you like 50 milliseconds versus 400 milliseconds? That is 8 times faster. How do you like 800% speed up? Because I like it quite a lot. And let's compare this 54 milliseconds to what we started with, 1042 milliseconds. We took 1042 milliseconds debug run speed, brought it down to 54 milliseconds. It's still a hell of a lot slower than release, but it's not like multiple orders of magnitude slower. It's now only, less than 1 order of magnitude slower. So, it's a huge increase. It's like 20, I forget, it's like 24 times faster. And that is going to go a long way towards allowing us to run our program in debug when we are developing it, instead of avoiding debug and just running it always in release. Because when we run in debug, it makes it a lot easier for us to catch errors early because of all the assertions that we've built into our program. So, yes, this extern template bullshit, definitely useful. It'll also improve your build times, which is a nice side effect. And the last thing I did was I just did the same idea, but I also added optimized versions for the chroma, sprite effect, and the substitution. So what you would basically do is, for your most commonly used sprite effects, you would put them in here in the extern template, and then here you would call them in this dummy function. This dummy function, by the way, it isn't called anywhere in the code, and it will be removed in linking. It only exists to give the compiler somewhere to instantiate these template functions so that they can be linked to the other parts of the program that are going to be looking for them. So there you go. This dummy function is going to give us our sweet optimized can. And that is it, I believe. Let me look at that is the last thing that I did here for optimization. And it's great. So now we can have our cake and eat it too. We've got, we're using std vector in our surface, and it is running fast in release and in debug. The only kind of regret that we have here, lingering remorse, is in, where's graphics dot, can't find it, graphics.h. Yeah, we couldn't use surface in here. It just costs too much in release build, and I'm not sure why that is. It might be something that we could massage out, but is it super worth it? Probably not. And it might be worth it to take a look at replacing this with a std unique pointer and seeing how that runs in release mode. But again, maybe I'll take a look at it later. Maybe I won't. But I'm definitely happy because we use surface so much. I'm definitely happy that we are able to replace that with a std vector, get some rule of zero. It's not true rule of zero, right? We've got to do a little bit in these move operations in order to handle the width and the height. when you pilfer from one surface, but it's close enough, and it's a lot better than what we started with. So there you go. There is rule of 0 versus rule of 5 in action, and perhaps more interesting for some of you, there is how you might optimize a debug build, optimize certain aspects of a debug build so that it is still usable during development.